Thanks, Kate. It's been a very interesting career I've had, and I've enjoyed every moment of it. And let me reflect. I'm a bit of a history buff. I have a fetish for history, and so doing this sort of thing, you've got to look back to look forward, don't you, sometimes? And you'll see history never repeats is a complete lie, unfortunately. My first recollection of the phenomena of tidal waves was when I was 11. And there was this Melbourne house painter, his name was John Nash, and he predicted that an earthquake and subsequent tidal wave would strike Adelaide's coastline on January the 19th, 1976. I was 11 years old. I've given away my age there. I'll read a little bit of an excerpt from a news article around the time. Don Dunstan was the Premier of South Australia at the time, safari suits and all that. The reason he gave for the imminent catastrophe was that God wasn't happy with Adelaide becoming a sin city and therefore had to be punished. With the social and criminal reforms of the Dunstan government and its reshaping of the 1970s South Australia, Adelaide had started to slip down that slippery slope. Dunstan had overseen increases in welfare, the liberalisation of drinking laws and censorship laws, and the abolition of the death penalty. Also under Dunstan, male homosexuality was decriminalised, and the age of majority was lowered from 21 to 18 years old. It was a time of immense change, and some people didn't like it. Anyway, I wondered what a tsunami or a tidal wave at the time looked like, and always wondered. But now with the internet, we all know what it looks like, don't we? So let me start by telling you what I will go through today. And I'm a bit of a history buff. I like military history. So I'll discuss the Crimean War and the attack on Pearl Harbor. It's quite relevant, especially today. Shirt fronting and all that. Look into the historical development of forced sea waves. It's another term that's used. Define the word complacency. Complacency is the crux of these very rare and very large events, but complacency is something that we must discuss. The writing of the book Frankenstein, or the Modern Prometheus, that's the full name of the book. The use of Morse code and how it relates to S-P. An attempt to define the governance processes within the UN, that's going to fail. Reveal the mysteries of the acronym KPI, a real public service term, that one. Understanding measurement errors and the model shortcomings, and give inspiration to hope that geoscientists can minimise the loss of life and property caused by the natural processes of the Earth. So that's what I'll cover, hopefully, as quickly as possible. So let's talk about the Crimean War. Well, it was in the mid-1800s, involved the Russian Empire, the Ottoman Empire, France, Great Britain, Kingdom of Sardinia, Italy, Greece, Egypt. There was war over the control of the Holy Land. It included locations like the River Danube, Caliphate, the Black Sea, Odessa, Crimea, Balaclava, Sevastopol, Sea of Azov, the Caucasus, the Baltics, the White Sea, and even as far away as Kamchatka on the Pacific side of it had the charge of the Light Brigade, the first war with photography. Florence Nightingale started nursing, and heavy artillery was prominent. Now, what's that got to do with tsunami? Well, there was this fella called Robert Mallet, who was a bit of an engineer. He was an Irishman, studied at the Trinity College in Dublin, graduating in science and mathematics in 1830. He designed a 43-ton, 910 calibre mortar capable of shooting a 1-ton shell a distance of 2.4 kilometres, and it was for use in the Crimean War. He was also famous for coining the terms, the words seismology and epicentre. But unfortunately for him, peace broke out and he wasn't able to use his device. The internet is wonderful, and now papers like this, which were hard to come by, are now readily available. And I spent all night absolutely enjoying myself reading his paper on the dynamics of earthquakes, being an attempt to reduce their observed phenomena to the known laws of wave motion in solids and fluids. And I'd like to quote something from the paper, actually the very beginning of it. The present paper constitutes, so far as I am aware, the first attempt to bring the phenomena of the earthquake within the range of exact science. By reducing to system the enormous mass of disconnected and often discordant and ill-observed facts which the multiplied narratives of earthquakes present, and adducing from these by an appeal to the established laws of the higher mechanics a theory of earthquake motion. This is in 1850, and even then we were wondering what it was that made the earth vibrate in such a violent manner. He then goes on to quote, and I have to read this because it's just beautiful. The last instance I shall quote is from the pages of the able and delightful Darwin. This is Robert Mallett's paper, in his Journal of a Naturalist's Voyage. In describing the effects of the great earthquake of March 1835 upon a building in the town of Concepcion, which you'll all recall in 2010 suffered a tsunami of magnitude 8.8. I'm sure you'll remember that one. After noticing the evidences of immense velocity in the shock by which the buttresses projecting from the nave walls of the cathedral had been cut clean off close to the wall by their own inertia, while the wall, which was in the line of shock, remained standing, he proceeds. This is Darwin talking, of course, now. Some square ornaments on the coping of these small walls were moved by the earthquake into a diagonal position, and you can see these blocks here of these obelisks that were actually twisted during the earthquake. A similar circumstance was observed after an earthquake at Valparaiso. Again, that place was affected by the 2010 tsunami in Chile. In Calabria and other places, including some of the ancient Greek temples, this twisted displacement, he proceeds, at first appears to indicate a vorticose, try and look that up in the dictionary, doesn't exist, movement beneath each point thus affected, but this is highly improbable. So he's having a bit of a go at Darwin, saying that he's not really defining the vibrations of an earthquake very effectively. Now I'm going to jump back another 100 years, about another 100 years, 1760. And I have to tell you here that the Jesuit order was very big at science. And this particular Reverend John Mitchell was wondering about the Lisbon earthquake and what it could do. And he wrote quite a lot about how he felt that an earthquake that was observed from the Lisbon, or the shaking that observed from the Lisbon earthquake, would have waves propagating along its surface from a point to where it had been produced. In other words, he could basically say that it seemed to originate from somewhere, and the shock wave would move out from that point, essentially trying to describe an epicenter, I guess. But what he supposes is to think of it in this way: a large cloth of carpet to be raised on one edge and then suddenly brought down again on the floor. The air under it, being by this means propelled, will pass along it till it escapes at the opposite side, raising the cloth in a wave all the way as it goes. So he describes the vibration of an earthquake in that sort of manner. And what he also did, though, was he was able to determine the arrival of the tsunami at various places that was observed, or the waves that are observed, and was able to use these times to project back the origin of the earthquake and the tsunami. So these were early thoughts of what's going on. There were not really much in the way of describing what's the actual process or mechanism for starting these events. Going back even further, there was a fellow by the name of Zhang Heng in the year 132 who developed a little device here that could work out where an earthquake's waves were coming from. And in fact, this was used quite effectively by the Han government, who found that they didn't believe that this system could work, but one of the balls dropped once, and they then later discovered that an earthquake had occurred some 200 kilometres to the north of where they were. And so they installed these devices all across China. Back to Mallet, he produced the very first map of an epicentre and described the wave motions as it travels through different bits of rock. And so again, very early indications of some form of wave motion across the crust and the ocean. And he even drew the first that I could find evidence of some sort of undersea rupture generating waves, and even showed as they approached the coastline how they would appear as multiple waves rather than one. So he had a very insightful view of the mechanism of these things. And he even drew some subterranean structures that were only really at that time only guessed. There was only theories about what was beneath the crust. And these were ideas of some uplifting of liquid mantle, if you like. So Robert Mallet stands as a pretty important figure in all of this, and he went on to study earthquakes for the rest of his life, and actually was the first person to really go and picture the damage from an earthquake in Italy here. And he was one of the first people to provide maps of damage, which gives us an indication of shaking, of course. So we're going to fast forward all of this history and jump through what's going on. This is from the International Research Institutes of Seismology. Robert Hooke, of course, developed elasticity, the theory of elasticity. Robert Mallet, you can see there, and we can see development of various techniques and instruments. First instrument used in the late 1800s. We can see Inga Lehmann. Inga Lehmann is very important because she discovered in 1930 the location of the inner core, and Benno Gutenberg with Richter discovered the mantle core boundary in 1914, and of course a gentleman by the name of Andrea Mohorovičić, where we get the moho layer, the layer between the crust and the mantle, all measured by looking at seismic waveforms and defining the phases through them. Just like we do currently with an ultrasound looking at the womb of a woman, we can get 3D images of inside the body of a woman, but we can do the same with the Earth with respect to earthquakes, using earthquakes as the source. Let's get on to tsunami. Well, they've been called forced sea waves, they've been called seismic sea waves, they've been called tidal waves. But in the 1940s, the international community decided that they would be called tsunami. And let's face it, of the top 20 tsunamis that have occurred, ranked by the number of fatalities, Japan has 10 of them. Unfortunately, Japan sits close to a zone of earthquakes that can generate tsunami, and plus they get tsunami from across the Pacific as well. And unfortunately, that's why we call tidal waves, seismic sea waves, etc. now tsunami. However, this image, which is sometimes attributed to tsunami, is actually not a tsunami. It's what's called an okinami, which is a rogue wave in the ocean. And it's from a series of woodblock prints by an artist called Hokusai, published in the 1830s. And the encryption in Japanese there actually says, "In the well of a wave off Kanagawa, and a wave in the open sea." So even though we sometimes see this as a tsunami, it really doesn't look anything like that. Some global tsunami statistics taken from the NOAA tsunami database. So we've had 2,520 recorded tsunami since 2000 BC to last week's Easter Island tsunami, which you may or may not have noticed last week. But if we look at that, of course, the vast majority of them in the last 200 years, 200 and a bit years. Obviously, records in modern times are kept much more clearly. But even back then, in 1800, there was no knowledge of what was going on. Total known deaths from tsunami alone, that is just from the tsunami waves, over 600,000. 85% from earthquake-generated tsunami. Of course, tsunami can be generated by volcanic eruptions and other things. Generally, it's those. But of those, 60% since 1800. Total known overall deaths, so the deaths from not just the tsunami but the volcanic eruptions and the earthquakes themselves, over 2 million in that database. So it's a significant impact on humanity. What I'll do now is just go through some of the larger tsunamis that have occurred in history. This one really started the ball rolling with the science of tsunami, the Great Lisbon earthquake of 1755. This earthquake was so strong, the vibrations, the shock wave from the earthquake were felt in the Caribbean. They were felt in Scotland and across Europe. It was considered an 8.5 to 9 earthquake with current thinking. The earthquake ended the lives of some 10,000 to 100,000 people. It's not really well known as to how many perished in this event. But needless to say, the city of Lisbon was basically destroyed, not only from the earthquake and the tsunami, but the fires that ensued later. And this event really caused a lot of scientific activity and included that John Mitchell work. The eruption of Krakatoa in 1883, that is a piece of coral that was thrown up about 100 kilometres into Java. That's a nice big piece of coral that came from Krakatoa. It was a very explosive eruption. It was an event that occurred in 1883. On the 27th of August was its major eruption. And it's considered one of the deadliest and most destructive volcanic events in history. Over 36,000 people died from that earthquake. Of course, the tsunami that was generated from there it's currently thought that the tsunami was generated by the collapse of the volcano and created tsunamis of the order of 30 metres around the coastline and even impacted Ashburton Rivermouth in WA. Although not a major tsunami, this is a good story, and you never get in the way of a good story. The Tambora eruption of 1815, this was the year without summer. Mary Shelley, Lord Byron, and her future husband, Percy Shelley, were at a villa in Geneva during the summer of that year in 1816. Unfortunately, there was no summer, and they were planning to spend a good time in Geneva enjoying the excellent weather. But it snowed and it rained and it was freezing cold the whole summer. And they spent most of that holiday indoors, reading ghost stories to each other. And so Lord Byron then said, well, okay, let's have a bit of a competition. Everyone write a ghost story. And Mary Shelley wrote Frankenstein. And that's the ghost story that seems to have, or the horror story that seems to have lived to today. Interestingly, there's other historical pieces of the Tambora event that created the year without summer. There's evidence that the famine that occurred, the crops that failed in the New England region of the United States, triggered a move west to find more arable land. So it also started some sort of motion to the west coast of the United States. So 90,000 deaths are attributed to that event, not all from the tsunami, clearly. This is not a number 2, but the Messina earthquake of 1783. Messina is the city that sits on the straits between Sicily and the mainland of Italy. And I like this old painting from this event in 1783 because it's got a lovely whirlpool, which we saw in the 2011 tsunami that hit Japan's northeast region. So these things are in our history and keep coming, but the real Messina earthquake of 1908, this was a truly massive event that ended the lives of 123,000 people. I must admit, I don't remember this event, and I only learnt about it when researching for this presentation. The tsunami took over 123,000, as I said, and it occurred just after Christmas, the 28th of December in 1908. The major cities of Messina and Reggio Calabria were almost completely destroyed from this horrible earthquake and tsunami. Now I want to define the word complacency. Now we can all look that up, a feeling of smug or uncritical satisfaction with oneself or one's achievements. But it must be understood that I've changed the example that was given in the Macquarie dictionary that I got this from. The community felt safer with a tsunami warning system, but there were no grounds for complacency. So, this is the theme of this presentation. It's about making sure that we never forget. Professor Phil Cummins was working at Geoscience Australia at the time. He is still working at Geoscience Australia, although now he is also a professor at ANU in the Research School of Earth Sciences. And he wrote a paper not 3 months before the 2004 tsunami that hit the Indian Ocean. And he mentions the fear that washes through coastal settlements in many southern Pacific islands. Australia rarely thinks about tsunami, yet it has an enormous mainland coastline that is rapidly being populated. There is an international tsunami warning system for the Pacific, but none for the Indian Ocean. How vulnerable is Australia to the risk of tsunami, and are we leaving our western coastal communities exposed? So at the time there was a tsunami warning system in the Pacific, which I'll come to in a sec, but there was nothing in the Indian Ocean. And he was sort of sounding the warning bells 3 months before this happened. This is the largest tsunami and the most devastating to lives and infrastructure in history. It occurred nearly 10 years ago now, and the word tsunami is now synonymous with big issues. We hear it in the press all the time. It's a tsunami crisis with respect to the finances, with respect to industries collapsing, with respect to anything major occurring, it's a tsunami. It's become part of the vernacular. It's the third largest earthquake recorded in recorded history. It's considered a 9.3. Well over 230,000 deaths occurred from this event, with over a quarter of those deaths occurring in countries other than Indonesia. What must be remembered here, or what the most important statistic from this event, is that 50% of the fatalities occurred near the epicentre and the other 50% of fatalities occurred nowhere near the epicentre. That 170,000 people that died in other countries or away from the epicentre in Indonesia did not need to die. There would have been enough time for a warning to go out to them and save their lives. 40 people were dragged out to sea off a coastal island in Perth, Penguin Island, from this event. It's, you know, Western Australia's on the other side of the continent and we often forget those little stories from WA. But they were all rescued, and they were rescued by fishing boats that happened to be out at the time. We even still hear about stories now. Just a few months ago, a 14-year-old was reunited with her parents after being dragged out to sea on some debris and finding herself on an island, picked up and thought her parents were gone. Almost 10 years later, she was on TV and her parents saw her and said, "That's our daughter." And then a week later, her big brother saw that and went, "That's my mum and dad." So we're still hearing the impact from those stories. Well, what's the first tsunami warning centre? In fact, this gentleman here, this nice looking gentleman, is stately, he's living right next to the large volcano that's now erupting, it's continuing to erupt in Hawaii, on the island of Hawaii. And he was the founder of the Hawaiian Volcano Observatory. He saw in his seismometers in 1923 a large earthquake that he worked out was coming from the Kamchatka region. And he then told the harbour master at Hilo that there was a tsunami potentially on its way. His warnings were not taken seriously, but at least one fisherman perished as a consequence. Nevertheless, an official tsunami warning capability in the US began in 1949 as a response to the 1946 generated tsunami in the Aleutian Islands in Alaska. And Ewa Beach is where it was, and it's on the coastline of near Honolulu, just out of Honolulu, and it's sitting on a geomagnetic observatory of the USGS. So it was co-located with the facility and maintained by the Pacific Tsunami Warning Centre today. It's a centre as a part of the National Weather Service of the National Oceanographic and Atmospheric Administration, NOAA. Well, what about the attack on Pearl Harbor, and what has this got to do with tsunami warning systems? In 1941, of course, this attack occurred. And I wanted to show this particular picture because that is Ford Island in the middle of Pearl Harbor, where the Arizona taking over 1,000 lives was bombed, and many other ships. But about where you can see these events occurring here is where the new Tsunami Warning Centre is now situated. They only just moved there a couple of months ago into a new building of NOAA that now sits on Ford Island. I thought that was pretty interesting. But the other aspect is, of course, I found a paper written by a Japanese tsunami warning academic who basically found that the Japanese tsunami warning system started around 1941 in response to the Senriku tsunami of 1933. But 1941, of course, all sorts of things were happening in the world at that time, and specifically by the Empire of Japan. And all of that effort that they were building, that tsunami warning system, was put on hold. And of course, as we know, the history of the war in the Pacific, the US then occupied Japan. And tsunamis don't care about human activity, and they continued to happen. And so the US decided, they wrote a proclamation in 1950 to the then government of Japan to formulate a tsunami forecast transmission system with comprehensive plans, and to do that within 60 days. It took Australia 4 years to build our tsunami warning system. They were required to do it in 60 days. This was said by the Japanese academic in his paper that this was a good thing by the occupying forces of Japan, in Japan, because it stopped them from moving away from the Morse code transmission of the S minus P times of the arrivals of the earthquakes. They no longer used Morse code to transmit those in the late 1950s and started to use teletype systems, which of course were replaced in the late 1960s by computer systems. So we've come a long way in just a period of about 70 years, I guess, 60 years. No more Morse code for sharing working out the epicentre of an earthquake. And of course you can see there that Japan has its own system. It's one of the best in the world, really. I'm often asked, aren't there more earthquakes at the moment? And the answer is, yeah, a bit. There is a bit. Certainly there was a lull in the 1960s and 70s, maybe 70s, 1970s. But generally, they're pretty consistent. And in fact, these are earthquakes magnitude 6.5 and above, and measuring only at 100 kilometres depth or less, which are the earthquakes that we use to define whether to press the button to issue a tsunami warning. Generally, earthquakes of magnitude 6.5 and above, near the coastline or under the ocean, or at depths where the focal depth, where the initial rupture of the earthquake occurs, is less than 100 kilometres, we will then issue a tsunami warning. So most of these earthquakes actually occur in those regions. Most earthquakes actually occur in these zones. And you can see there that there are 402 tsunami alerts. 402 tsunami alerts since 2006 tsunami of the Indian Ocean. And that's an average of about one a week. So the Tsunami Warning Centre that we operate jointly, Geoscience Australia operates jointly with the Bureau of Meteorology, actually issues a tsunami warning of some basis once a week across the Indian and Pacific Oceans. Some recent tsunami research by Professor James Goff of the Tsunami Research Centre at the University of New South Wales. This is, I don't believe this is published yet, but he's sent it to me to show what the current findings are. And we can see here that he's looked at paleo tsunamis, looking at what tsunamis have potentially occurred in prehistory. And he's looked at what evidence there is in the records across governments and the media that may attribute to tsunami. And he's found that there were 3 deaths in Queensland, 7 in Victoria, surprisingly. We don't consider Victoria a high-risk tsunami state, and 1 in Tasmania. None in Western Australia. But we should remember that we tend to look at earthquakes and tsunami in a human impact sense. And of course, the human population has moved from 2 billion in the 1920s to close to 7 billion today. So the impact on humanity, the spread of humanity, is going to increase. The impact of the tsunamis will impact humanity far more with our fondness for the coastline, I guess. This you're not supposed to read. You're supposed to look in awe at and wonder, how does the United Nations function? And you can see that it would be quite difficult. This is the first level of the United Nations organisation chart, and it's quite comprehensive. It covers all sorts of things, But the area that we work in the international space of tsunami warning, is in UNESCO, the United Nations Educational, Scientific and Cultural Organisation. It forms part of the Economic and Social Council of the programs within the United Nations. We also play in the space of the United Nations International Strategy for Disaster Reduction, which is where all forms of natural disaster are discussed in the international space. I attend meetings of the IOC Intergovernmental Coordination Groups of the Indian Ocean Tsunami Warning and Mitigation System and the Intergovernmental Coordination Groups of the Pacific Ocean Tsunami Warning and Mitigation System. So the nations in those two basins get together once every 2 years and discuss how we can improve the tsunami warning systems that we have and how to better educate the population on the risks and hazard from tsunami. As I mentioned, the Pacific Tsunami Warning System has really been in place since the 1950s. And there was no Indian Ocean Tsunami Warning System. But the area did get together, and the Indian Ocean countries got together after 2004 and decided that the Indian Ocean system would be one of national systems. So 6 nations put their hand up to become a tsunami warning part of the tsunami warning system for the Indian Ocean. Unfortunately, only 3 have been left standing. That's Australia, Indonesia and India. Those 3 tsunami warning centres work together to provide tsunami advice to all the other nations in the Indian Ocean. In the Pacific Ocean, the Pacific Tsunami Warning Centre and the Japanese Meteorological Agency in Tokyo provide tsunami warnings across the Pacific. The Japanese Meteorological Agency tend to do it as a backup to the PTWC. There are also tsunami warning system for the United States in Alaska, and there is a Chilean tsunami warning centre as well. How do we do this? Well, seismic waves travel through the Earth at about 8-9 times the speed of sound. So that's the first indication. As I showed you earlier, most tsunamis are generated, something like 70 to 80% of tsunamis are generated by earthquakes. So we need to have a strong global seismic network of seismometers, all connected in real time to the warning centres. And this is a network that's global, that's where we sort of share our data with each other. Not everybody shares. India doesn't share. China actually delays its data by half an hour, unfortunately. They're nuclear states, so they don't particularly want us to see maybe some nuclear testing that they're doing. So unfortunately, it'd be nice if the nations that are united across the ocean, the globe would operate equally, but unfortunately not all nations share real-time data. Although nevertheless, we have enough to perform the accurate measurement of these earthquakes. The Comprehensive Nuclear Test Ban Treaty Organisation shares its data with us, the local seismic networks from nations, and there's also a seismometers in schools program that's being developed by the Australian National University, which is helping. There's an array of deep ocean bottom pressure sensors which is used to measure the sea level. This is maintained. You can see the yellow ones here maintained by the Bureau of Meteorology. These are Australian stations. Unfortunately, Indonesia were unable to get theirs going. There's one there. Sorry, that's a Thai, no, that's an Indian station, that one. And there's a Thai station there. The red ones are all ones that come from the US. Japan recently put these in after the earthquake in 2011, and there's a few put in by Chile. They really struggle to operate. The buoy is actually just a communication device. There's no measurement done at the buoy. The measurement is all done by a pressure sensor on the ocean floor about 4 kilometres down. A tsunami has a wavelength of about 150 kilometres in the open ocean. It travels at about the speed of a jumbo jet, 800, 900 kilometres an hour. And it actually is impacted by the ocean floor, the topography of the ocean floor, and so it can be measured from the ocean floor. Tide gauges as well are used, and they're used to measure the sea level, but of course they're on the coastline. So unfortunately, sometimes the tsunami, first indication of the sea level measurement of a tsunami is on the coastline. So what about the Joint Australian Tsunami Warning Centre and key performance indicators? An earthquake occurs and then we know about it. We cannot predict earthquakes. Not likely that we ever will. So in about 8 to 10 minutes, depending on the location of the earthquake relative to the seismic network, we're able to issue a first indication of an earthquake, its magnitude, its location, and its time of rupture. Within 2 to 5 minutes after that, a bulletin is then published through all sorts of avenues of communication, to harbour masters, to lifesavers, Surf Lifesaving Australia, all emergency services, within 2 to 5 minutes. So you've got about, let's say, maximum 15 minutes, which means that if you're close to the rupture of the earthquake, then of course you're not going to see a warning. People these days, well, young people these days use Twitter. And this is our Twitter account that we use at Geoscience Australia to, as soon as the alert goes out, we publish the information on Twitter. It goes on Geoscience Australia's website. There are emails sent to various people across the nation. The public also tweet themselves. After the earthquake occurs, the first step that the Bureau of Meteorology does as part of the Joint Australian Tsunami Warning Centre is select a pre-computed model. And in this case, this is the one that was used in the April tsunami that occurred this year in northern Chile. And you can see that's a magnitude 8 earthquake. And this is the tsunami wave height in the deep ocean. And it gives some form of indication of what can occur at the coast, but not completely. And bulletins are then published onto the website and through other means. I need to explain that there are only 3 threat levels for a tsunami. No threat, meaning that we know an earthquake has occurred and a tsunami has been generated, but there's no threat to any part of the Australian coastline. A marine and immediate foreshore threat. Sounds a bit odd that the tsunami is a marine threat, but that's the terminology that's used. It's a warning of potentially dangerous waves, strong ocean currents in the marine environment, and the possibility of only some localised overflow into the immediate foreshore. There's a land inundation threat, warning for low-lying coastal areas of major land inundation, flooding, dangerous waves and strong ocean currents. To go any, and you'll notice there's no mention of wave height. That's deliberate. If we said what the wave height is predicted to be at all the locations around the coastline, you can imagine how long that would be. But not only that, it starts to allow people to think that a 1 metre tsunami is not dangerous, or a ½ metre tsunami is not dangerous, when in fact they really are extremely dangerous. And as part of our effort to help the Indian Ocean countries, the Joint Australian Tsunami Warning Centre forms part of the regional tsunami service provider for the Indian Ocean Tsunami Warning and Mitigation System. And this is published to allow governments overseas in the Indian Ocean to issue warnings. We do not issue warnings. The Australian government cannot issue warnings to other sovereign governments, to other sovereign citizens. It is the responsibility of each nation to advise their citizens of what's going on. But we provide that information so that they can then do it in their own language and in their own manner. State emergency services have plans in place for when it occurs in Australia. And we regularly exercise these events. In fact, every year we run a tsunami exercise that involves the tsunami warning centres across the oceans, and also the state emergency services and government agencies. Inundation modelling can be done. This is a simulation of a magnitude 9 off the Kermadec Trench. Kermadec Trench is that trench between Tonga and New Zealand. And this is a coastline near Wollongong. And we can see from this sort of modelling and knowing the topography and the bathymetry of the ocean floor, the topography of the ocean floor, that we can then model what may the likely impact be. You cannot run these in real time, although we are looking towards doing that in the future. These things are they're not particularly accurate because it obviously relies on the data of the sea level, the ocean floor, I should say, and that's changing. So gives you an idea of where the inundation could potentially be and the damage can occur. This is good for pre-planning and preparedness and defining evacuation routes. Just stop there. But unfortunately, the bathymetry of the world is hardly known, even though we might go onto Google Maps and look at the incredible structures under the ocean. 80% of the ocean floor has not been directly mapped. It's all mapped from satellite measurements of gravimetry and sea surface altimetry. So the ocean floor itself is largely unknown, and in fact we're finding, looking for MH370 in the Indian Ocean, that we're using side scanning bathymetric techniques to get better images of what's going on down there in terms of the topography. Tsunami hazard assessments are also done. You're able to work out where earthquakes are likely to occur, and clearly they occur at plate boundaries. And for us, the biggest hazard is the northwest of Australia, but there is also a hazard to the east coast of Australia as well. Those tsunami predictions of Adelaide are somewhat, yes, well. Australia also plays with aid in terms of the Australia-Indonesia Facility for Disaster Reduction. We participate with the Indonesian government in helping to mitigate the risks from natural hazards, both volcanic and earthquake and tsunami in that region. With CSIRO, in fact, we have developed, or CSIRO have largely developed with our input, a Twitter alert system. So this is sort of like the future of these things. Humans are great at feeling earthquakes, and they feel them really quickly. And for some reason they like to tweet about it. So in actual fact, this is the event that occurred in 2012 in Victoria. It was a magnitude 5.4, and there was a lot of tweeting about that. In fact, we got the Twitter alert email before we could see the seismic signals. Pretty quick on those Twitter things, aren't they? What about new products? Where are we going? In actual fact, when I was got this data, it was experimental, but it was just started only 2 weeks ago. The new products from the Pacific Tsunami Warning Centre actually define coastlines like the Australian system does and the Indian Ocean system does. They needed to play catch up because in the past they just said there was a tsunami warning in place for Australia, which for us was a little bit too coarse. So now they've sort of caught up, but they've actually passed us. They're now using an earthquake rupture model to generate the tsunami model on the fly. So they're actually not using pre-computed tsunami models and choosing the best one that relates to the earthquake. They're actually using the earthquake data, running the tsunami model, and using it to generate that polygon map of likely threat zones. And it also creates tsunami threat levels at various coastlines across the whole Pacific. You'll notice that the Canadian and Alaskan and west coast of the United States is not dotted. It's largely due to the fact that there's a national tsunami warning system in the US that covers that space. And now, of course, smartphone applications. There are hundreds of earthquake smartphone applications, and they all connect to various earthquake feeds. And of course, this one is connecting to the Geoscience Australia earthquake feed, and you can see earthquakes appear as soon as we press the button within that 8 to 10 minutes. There are now automatic earthquake analysis going on. The New Zealanders, you know, after Christchurch, they've been able to upgrade their systems, and they're able to issue an earthquake alert within 39 seconds of the rupture. And in fact, so much so that those earthquakes are still going on as they are getting more and more detail and the data being recorded. Still being reviewed, of course, 13 minutes later by some seismologists, and that's the best quality because, you know, you can't trust computers, can you? I'd like to share with you, just as I finish, something else, and that is that these events are massive. A magnitude 9 earthquake that occurred in Japan, that's the vector from a GPS network across, they've got lots of GPS across the nation of Japan. And we can see that the earthquake actually moved the island of Honshu 5 metres to the east, and it depressed the crust about 1.5 metres along the coastline. The earthquake, a magnitude 9 earthquake, has the equivalence of about 3 million blasts of nuclear bombs going off at once. It occurs over time and space, so it's not a point. The point is the origin of the earthquake, where the earthquake starts, but it's a complicated beast. And as a consequence of that, the model that's produced in the first 10 minutes is quite possibly difficult to ascertain. The actual rupture of the crust is not simple to determine from remote sensors of seismometers. You can't put GPS systems on the ocean bottom either. It's a bit tricky. So this is the same event. This is a magnitude 9 south of Java. It could be there or it could be there. The same event could be in both places. The rupture of the earthquake can occur symmetrically. It can occur at one point and move to the east or to the west. And as a consequence, the model that's developed could be 500 kilometres out. So what do we have to do to combat that? We have to try and measure the rupture of the earthquake in real time. And that's what we're trying to do at Geoscience Australia within a seismic array in the Pilbara, located in the Pilbara. Actually watch the rupture of the crust occurring over time. Just back to complacency. Monuments fight complacency. This was something that was really rammed home after the Japanese event. They built monuments to remind people. This monument here was built back in the 1800s, and it says, never build houses below this point. What do you think happened? Complacency set in. They had a tsunami wall built, so they thought that was okay. After 2011 event on 11th of March, this one was built by a lady, and it says here, the memorial stone of the tsunami for 2011, just run uphill. Don't worry about the others. Save yourself first and tell the future generations that a tsunami once reached this point, and that those who survived were those who ran uphill. So run uphill. The point here, she talks about, this is the lady, the owner of a hotel that was on the coast, that actually went back into the water to try and save people, and she survived miraculously. The problem was a lot of people actually ran to the coast to save people, and they're the people that died. Other people actually got out themselves. So if everybody does the same thing and look after themselves, then everyone is saved. And that was a great lesson from the Japanese event. So on that note, I'd like to thank you for listening, and thank you.